NASA launches groundbreaking solution to launch new spacecraft, replacing Space Shuttle. Welcome back to the Elon Musk Signal channel. While Boeing's troubles continue to delay the Starliner, Sierra Space's Dream Chaser shines like a beacon in the night sky, keeping our hopes high. Sierra Space and NASA have just announced exciting news about the single-winged commercial spacecraft designed to serve the International Space Station, ISS. The Dream Chaser has achieved significant milestones in its final tests before its scheduled launch at the end of 2024. So, what can we expect from Dream Chaser's maiden flight? What hurdles has Sierra Space overcome to reach its current milestones? Let's explore in this video together. On May 18, inside a climate-controlled shipping container from NASA's Neil Armstrong Test Facility in Sandusky, Ohio, the Dream Chaser spacecraft named Tenacity arrived at Kennedy Space Center, joining the cargo module Shooting Star, which had been there since May 11. Upon arrival at Kennedy, the engineering team moved the Dream Chaser Tenacity to the high bay inside the spacecraft processing facility, where it will undergo final checks and processing. Before the anticipated launch later this year, remaining pre-flight activities at Kennedy Space Center include compatibility and noise and electromagnetic interference testing, finalizing the spacecraft's thermal protection system, and integrating the final cargo. Over the past few months, Dream Chaser and Shooting Star have undergone rigorous vibration, impact, and vacuum thermal tests at the large-scale Neil Armstrong Test Facility. In December, the engineering teams conducted a rendezvous test with the launch partner CRS Space's United Launch Alliance, ULA, using a separation system that will deploy the spacecraft from the upper stage of ULA's second Vulcan Centaur rocket. These two powerful vehicles were then stacked atop each other in a launch configuration on the world's most powerful spacecraft shake table inside the center's mechanical vibration test facility. The vibration test, conducted over 5 weeks, simulated the harsh conditions of a Vulcan Centaur rocket launch. Following the vibration tests, another separation test was conducted, this time with the separation system between the Dream Chaser and Shooting Star to simulate the dynamic separation environment of the two vehicles before re-entry and reintegration. Subsequently, Sierra Space and NASA test teams moved Dream Chaser and Shooting Star to the Armstrong Propulsion Test Facility to undergo thermal vacuum (TVAC) testing. This test simulates the actual thermal environment of spaceflight and is crucial for mission success. Over 5 weeks, Dream Chaser and Shooting Star underwent numerous thermal cycles in a vacuum environment, with temperatures ranging from -101 degrees Celsius to 121 degrees Celsius. Additionally, the engineering teams conducted functional tests at stable temperatures to verify system performance. Passing the TVAC test confirms the Dream Chaser is ready to face the harsh environment of space. All final tests are expected to be completed by the end of this fall and launched by the end of the year. Dream Chaser, Tenacity, will be the first in a line of versatile reusable spacecraft designed to transport cargo to low Earth orbit. So, what are the highlights that set Dream Chaser apart? Firstly, it's the flexibility of its engines. Equipped with internal engines with 3 operating modes, Dream Chaser can perform precise maneuvers when docking with the ISS. Secondly, the fixed-wing design allows Dream Chaser to return to Earth's atmosphere and autonomously land on the Kennedy Space Center runway with a deceleration rate of 1.5 g. This safe landing capability is compatible with commercial runways worldwide. The fixed-wing design enables Dream Chaser to land more safely than capsule re-entry methods. Thirdly, accompanying Dream Chaser is the compact cargo module Shooting Star, capable of carrying up to 3,175 kilograms of cargo and featuring an exterior storage compartment designed to self-destruct upon re-entry. This means that approximately 3,860 kilograms of waste will be completely incinerated thanks to Earth's atmospheric pressure. The reusable capability of Dream Chaser significantly saves costs compared to single-use spacecraft. According to the plan, Dream Chaser, Tenacity, will be launched from Space Launch Complex 41 at Cape Canaveral and then dock with the International Space Station, ISS, for approximately 45 days. After completing its cargo delivery mission to the ISS, Tenacity will bid farewell to the Shooting Star module and land horizontally on the Kennedy Space Center runway. Dream Chaser is expected to return to Earth with approximately 1,588 kilograms of cargo, including crucial scientific data from experiments on the ISS. Sierra Space has announced they will operate a production line to assemble shooting star modules, with a new module for each mission. NASA has also planned at least 7 cargo missions with Dream Chaser, Tenacity. Additionally, Dream Chaser's cargo capacity can be expanded, and mission durations could extend up to 75 days if everything progresses smoothly. However, Sierra Space's ambitions do not stop there. They are producing another Dream Chaser named Reverence, equipped with life support systems to transport astronauts. Developing a crewed version of Dream Chaser, Reverence, opens up opportunities for future commercial space tourism missions. Dream Chaser has been in development since 2004 and was initially planned to participate in NASA's Commercial Crew Program. However, Dream Chaser was surpassed by Boeing and SpaceX in 2014, when these two companies were awarded contracts worth $6.8 billion. SNC failed in this challenge, and the future of Dream Chaser became uncertain. The main reason could be the landing gear malfunction during a spacecraft drop test in late 2013, causing Dream Chaser to veer off the runway, raising concerns among government officials. In fact, building a spacecraft capable of landing like an airplane is not simple. Just skimming through Wikipedia, you'll find a list of about 60 failed spacecraft projects since 1944. However, Dream Chaser quickly regained NASA's attention. In 2016, a small unmanned version of Dream Chaser was selected by NASA to become the first spacecraft to transport critical cargo to and from the ISS. This was a sensible move by NASA, especially considering Dream Chaser's comeback marks a new milestone in the collaborative efforts between the government and private companies to develop the aerospace industry. While successfully conducting a flight with Dream Chaser is a significant achievement, we also need to acknowledge the reality that both Dream Chaser and Boeing Starliner have undergone lengthy development processes and faced numerous delays. Both have had to undergo countless tests and overcome technical glitches during development. But the difference lies in how the two companies handle these setbacks. While Boeing seems to rush through technical checks, always believing that improvements will bring reliability, Sierra Space takes a slower but more systematic and thorough approach to evaluations. Dream Chaser may not be as flashy as its competitors, but hopefully, upcoming events will unfold smoothly as they are on the verge of a new breakthrough, bringing joy and pride to everyone. Dream Chaser is not just an ordinary cargo transporter but also a symbol of the aerospace industry's far-reaching ambitions. The first flight of Dream Chaser promises to usher in a new era for space missions. Thank you for watching the entire video. Please leave your comments on today's broadcast. Don't forget to like, share the video, and subscribe to the channel for continuous updates on interesting information. Goodbye and see you in the next video.